Hi guys, in this tutorial we will talk about item 6 in effective Java, avoid creating unnecessary objects. So let's have a look example. If you define a string message variable with a value hello effective Java 6, and if you define another variable which is exactly has same value with the first one, and you compare the result of these two variables, you will get true as a result. Have you thought about it why you got true? Because Java works differently. If you have two different object string which has the same value, Java allocates same memory address in the memory. So it doesn't allocate extra memory space for us. However, if you define a string variable by creating a new string like hello effective Java item 6, but obviously this is a fully new string, and then second variable which is message2 hello effective Java item, when you compare of these two object reference, you will get result as false. Why? Because Java works differently in here. You are creating a new memory space when using a new keyword. When you use a new keyword, Java will understand these are two different objects and you will allocate a two different memory address in the memory. So this will reduce the performance of the application because we don't have unlimited memory, we have limited memory. That's why Bloch said, avoid unnecessary object creation. This is one of them. Talk about autoboxing. Autoboxing is converting a primitive type to an integer wrapper object type. This is an autoboxing. Unboxing is converting a wrapper type to a primitive type, unlike autoboxing. It basically unpacking a wrapper object to a primitive type. They can be for integer, long, double, decimal, or similar types. Let's have a look at example for item 6. And first example that are we gonna check, which is a string object creation. If you have a look line 77, we are creating an object in here, string message and new, which means we are creating a new string object. And then we have string message 2 and string message 3. All these three have exactly the same message. And in line 12, we are comparing the reference of message variable and message 2 variable. And line 14, we are comparing the reference of message 2 and the message 3. So what are we gonna get? We're gonna get false for line 12, but true line 14. Why? As we know from Java, when you create a new string object, even though it has the same variable, it allocates a new memory address in the memory. However, if you directly assign a string value to a string object, it won't create extra memory. It won't allocate extra memory address in the memory. It will find the equivalent of this value and keep the reference there. So this will enhance the performance of the application. That's why Bloch says avoid unnecessary object creation, because unnecessary object creation creates worse performance. We are allocating the memory. We don't have unlimited memory space. This is a very crucial to understand. And what we need to do from now on, we need to make sure that we are not creating extra complexity in our memory. At the same time, we should create reusable objects and reusable variables when we need it. We shouldn't create variable and object every single time. That's why we are presenting singleton pattern, and that's why we are always care about the singleton pattern, because singleton pattern saves us to create extra objects every single time when it's not needed, which is very important to understand. Let's run this application. As a result, we will see false because they don't have same reference. And last one is true, they have the same reference, even though they are two different variables, because Java allocates one memory address for us for these two same values. Another example is very important to understand: autoboxing and unboxing. So as you can see in the video, autoboxing is converting a primitive type to a wrapper type. Unboxing is converting a wrapper type to a primitive type. So as you can see in line 22, we created a wrapper type variable sum. And then we are doing some addition operations in here. There's until integer max value. We are addition all these values step by step and returning the result at the end. So what are we going to check in here? We're going to check first, what does it mean line 22 in terms of autoboxing and unboxing? So this line performs autoboxing because right of this equality, which means it's a primitive type, we are first autoboxing this primitive type to a wrapper type. And we are making this primitive type a wrapper type. And now we know sum value is a reference object and it has value as 0. But then line 23, we have a for loop. This is not important, but line 24, what is the equivalent of this operation? It is sum equals sum plus I. And when we do the sum plus I, which means we are first doing an unboxing operation because we know sum is a primitive wrapper type and we have to do it first unboxing operations. And then when we want to return the result to assign the sum object, we are returning it as we are performing autoboxing operations. So which means we are operating or performing two different operations in this line, unboxing and autoboxing. Line 25th, we are doing a second time unboxing operation, which is unboxing because it returns a long primitive type. So as you can see, this whole image, everything happens under the hood. All those mean we are creating unnecessary objects and we are allocating space in the memory during the runtime. This is not that we don't want to do, we want to use our memory efficiently. That's why we have to pay attention. Autoboxing and unboxing operations. Let's check the performance first. How can we check the performance? I will do something very basic things. I will write a start time equals system dot current time millisecond, and then I will do something else, and time equals system dot current time millisecond, and I will system out print line result and time and time minus start time. Yeah, so let's run this first and what we will see. It will take time. As you can see in here, results starting time and end time is 5,856 milliseconds for autoboxing and unboxing operations. Let's prevent autoboxing and unboxing operations for this logic. How can we prevent? Of course, when we convert this wrapper type to a primitive type, the thing we will see is from now on it won't performing any autoboxing and unboxing operation, and the performance will steadily increase. Let's see it. Run it. And as you can see, it's almost four times faster than before. So that's why George Bloch says, avoid creating unnecessary object creation, which is really, really important to understand. This is all for this video. Thank you for watching. See you in the next video.